My foot's on the floor. I feel alive! So this video is all about acceleration. We're going to be looking at what acceleration is and how we measure it. But before we do that, we need to work out a couple of things that are to do with acceleration. So words that are associated with acceleration. So the first word we're going to look at is speed. We can calculate speed by dividing distance by time. So if we know how fast something's gone and how long it took to get there, then we can divide those numbers and we can calculate the speed of the object. Now, speed is a scalar quantity. That means it has size and no direction. You could say your computer's fast, as well as you could say someone runs fast. When we think about objects moving, we use the word velocity, because velocity is a vector quantity. That means it has direction as well as size. So we're going to be looking at velocity today, and we're going to be looking at acceleration. Now, to calculate acceleration, we're going to get to that later in the video. But before we do that, we need to get in something that's really fast. And I've got an idea. I told you I had something fast. This is a Hyundai Getz. It's got a 1.1 litre engine and approximately 69 brake horsepower under the hood. I don't know how they fit the horses under there. These are limited edition, but they made about 1.5 million of them in the end because they were so popular. We're going to jump inside the Getz and we're going to take this from 50 to 70 miles per hour, and then we're going to calculate the acceleration. Okay, so to maximise power of the Hyundai Getz, I've had to turn the air conditioning off and open up all the windows. It's going to get noisy. So what we're going to do is go onto the arterial road, the A127. We're going to take this baby from 50 miles an hour all the way up to 70 miles an hour. I've got an assistant in the back who's going to time that for us, and then when we get back we can calculate our acceleration. So this car can do 0 to 60 in under a minute. We need to calculate the acceleration from 50 to 70 miles an hour. So I'm going to get this car up to 50 and start the clock. I'm pushing it hard. My foot's on the floor. I feel alive! We've now hit 70 miles an hour. Stop the clock. So, to calculate the acceleration, we need to use a special equation. Now we're going to go back to the house and we're going to calculate it now. Okay, so we're going to look at those calculations now. And before we do that, we need to meet the equation for acceleration. Now the equation is on the board here. If we look at the equation, it's got lots of different variables in it, and we need to know what those variables are. So let's start at the top of the triangle. We've got V and we've got a U. Now V is our final velocity. Okay, and U is our starting velocity. So V minus U means you have to take away the final velocity from the starting velocity. Now underneath the bottom of the triangle we have acceleration for the A, and over here we have time. So let's take a look at where our numbers fit into this triangle so we can do the calculation of how fast my car accelerated. Okay, so my V was my final velocity, which was 70 miles per hour. My U, so my starting velocity, was 50 miles per hour. My time was 21 seconds. So what do I need to do with this equation to work out the acceleration from that point of my journey? I need to do v minus u, which would be 70 minus 50, and then I would need to divide all of that by the time it took, which was 21 seconds. Now if I do that calculation, I end up with the answer of 0.95. Now we need to understand what that number means. We know it's the acceleration number, we don't know the units for it yet, and we've got a few different units going on already. So at the moment, when we were driving my car, it was the speed, the velocity was measured in miles per hour, and that's not ideal in physics. We like things to be in meters per second when we're talking about velocities. So at the moment, my answer is actually in 0.95 miles per hour. I'm writing it like this is fine. And then it's per seconds. That means that my car was accelerating nearly 1 mile an hour per second as its acceleration. But like I said, we don't like it like this. We like to have things in meters per second, and for acceleration we like to have the units in meters per second squared. So we're going to scrap this and do some conversions to get our answer the way it should be presented. Now to convert it, I know that 1 mile per hour, 1 mph, is equal to 0.44 meters per second. So I can now start doing some conversions to get my velocity, my final velocity, my initial velocity into the correct format of meters per second to redo the calculation. So that means my final velocity was 31 meters per second. My initial velocity, or my starting velocity, u, was 22 meters per second. My time still stayed the same. My time is still in seconds, that's absolutely fine. So my time was 21 seconds. Now when I go to do the calculation again, we can make a bit more sense of it. So v minus u, so that's 31 minus 22, okay? And that's going to give us an answer of 9, divided by our time of 21 seconds. Now if we do that calculation, what we actually get is 0.4 as our new acceleration number. And what does that mean? Well, let's just clear this screen quickly so we can make more sense of it. So like I said before, when we did it in miles per hour, it was in miles per hours per second. Now we've converted everything to meters per second. This makes the final answer 0.4 meters per second squared. Okay, and to understand that, we're going to go back to our equation. Now in our equation, we have velocities in the top part of the triangle. Those velocities are already in meters per second. We've also got time at the bottom of the triangle, and that's already in seconds. So when you divide meters per second by seconds, you're going to end up with, I'll just get my pen back, meters per second, okay? And that's the same as meters per second squared. So on a final note, acceleration is always measured in meters per second squared. If it's a deacceleration, i.e. something is slowing down, then it will be a minus number. When it's a positive acceleration, it will be a positive number.